Hello, everyone. My name is Christopher Colean, and I am a graduate from the Ferris State University Manufacturing Engineering program. There's me down in the bottom right. I'm excited to take you through a summary of my final capstone project for my manufacturing facility design class. To start, I'll be going through a basic project overview. Because of the COVID-19 pandemic, my class could not meet in person, but this did provide inspiration for the scenario presented to me as a manufacturing engineer. The scenario being that the FDA has contracted a manufacturing facility to make emergency ventilator controllers for hospitals in the Great Lakes region in the United States. So based on this situation, create an entire manufacturing facility. So the first thing I did was start with some market research. This generated my first little bit of information to help me get tack time and things like selling price. Next, I had to figure out how a ventilator controller functioned and how it was built. The basic function of a ventilator controller is to serve as a doctor or nurse, primary means of getting air to a patient. The controller can control flow rate, volume, pressure, etc. The controller has a few components in it that are key to how it works. The first being the main control board, which connects to the LCD screen and the buttons, the transducer board, which converts the air pressure measurements into meaningful numbers that doctors can adjust. The very outside is a housing that is molded PVC that protects those internal circuit boards. And last but not least is the power supply unit, which uses an AC-DC converter in addition to having a backup battery just in case the power goes out and the hospital still needs to get air to its patients. With all of that in mind, the company I came up with is Rapid Assembly Solutions. Rapid Assembly Solutions is a small-scale manufacturer with a specialty for quick turnaround times on assemblies, with the mission statement being to provide innovative and creative solutions to our customers' toughest challenges. I figured, since this is a school project, I would make the facility tailor-made to this specific application. So it just happens to be a coincidence that Rapid Assembly Solutions specializes in circuit boards and injection molding. The key performance indicators of this company are safety, quality, delivery, inventory, and productivity, with a special focus being put on quick delivery times. Next up are the company values. I kept these in mind while designing the facility. First off is the value of community. I feel like this often gets overlooked in projects like this, and for most companies I looked at as examples, community was often the first on their list, so it's the first on my list. Second is quality. Custom reserves a quality product 100% of the time. Next up is continuous improvement. And last but not necessarily least is safety. Again, providing a safe workspace is a top priority. And also, I would like to give a shout out to Toyota specifically. They provided me with excellent examples of company values. The last thing I'll be going over are some details about the facility itself. I chose Grand Rapids, Michigan for the location of the facility for two reasons. First, and the obvious reason, Michigan is centrally located within the Great Lakes region. Secondly, the workforce in West Michigan is already suited for manufacturing, with plenty of talented engineers, machine technicians, and operators looking for new opportunities. The manufacturing facility itself is 8,000 square feet, which is enough for all machinery, assembly cells, office space, bathrooms, and inventory space. The facility also comes with a 10,000 square foot parking lot, which is a bit of overkill, but could be used to expand the facility when it gets more business. Lastly, the facility would cost $333,000 to build it from the ground up. I'd like to close out with a couple of thank yous. First, to all my Ferris professors for supporting me through the years. Second, to the University of Florida for helping specifically with this ventilator controller project. And then a special thank you to my wife for dealing with all the late nights I spent up doing homework. I have only scratched the surface of this project, And if you are a potential employer, manufacturing engineering student, or simply an interested individual, you can contact me at the email below. Just put YouTube presentation in the subject line and I will send you the full project.